Hello, welcome to Algebra 1 with Miss Andrea. Today we're going to look at the slopes of these parabolas that we've been getting into. So we have been studying parabolas and quadratic functions and looking at how to graph them and whatnot. But what do you remember about slopes? Well, remember, a slope is a rate of change. Specifically, when we looked at slopes before, we were looking at linear functions. And so the linear function is here in black for us. And a linear function has, remember, what we call a constant rate of change. So you can choose any 2 points on this line. Doesn't matter which two. You can choose point 4 and 5, point 4 and 1, point 2 and 3, point 2 and 4. It doesn't matter, any 2 points. And you can calculate the rate of change and it will be constant or the same thing, no matter what 2 points you choose, whether they're right next to each other or far apart. It does not matter. So that is a constant rate of change, gives us the slope, right? Remember, we called that m, y equals mx plus b. M was the slope. But when we think of a quadratic function, you're not going to have a constant rate of change. The change that's happening in your quadratic function or your parabola is going to change no matter where you are. So if you take this point and this point, the rate of change between those will be different than the one from this point to this point, okay? And so essentially what's happening is when you calculate the rate of change, you're creating a straight, you're calculating the slope of the straight line that passes between those two lines. And so you can see just between the two dots that I picked right here for this one and here for this one, those straight lines clearly have different slopes. One is positive and one is negative. So already you can see that there's going to be different rates of change based on the 2 points that you have. And so the rate of change is constantly changing in a parabola. It could be a minute change or it could be a big change. However, it's always changing no matter what 2 points you have. You're going to have, if you have 2 different points, you're going to have a different rate of change. All right, or a different slope. And so here we have a parabola and we say, well, what's the rate of change or the slope between these 2 points? The first one has a ordered pair of 2, 4, and the second one has an ordered pair of 3, 11. Well, at this point, you need to remember, what is our formula to figure out rate of change? Well, it's the vertical change or the change in y divided by the horizontal change or the change in x, right? So let's look at this and let's call one of these 0.1 and the other one 0.2. I'm going to go here with this as 0.1 and this one will be 0.2. So I'm going to put my y's up for my 0.1 first. So y goes on top, which is 14, because remember this is x and this is y. And then x goes on the bottom, which is 2. So I take care of 0.1 first, and then I'm going to put minus. And then I'm going to put 0.2 next. 11, my y goes on the top, so 11's on the top, and my x goes on the bottom, so 3 is on the bottom. So 14 minus 11 is 3. 2 minus 3 is 1. So 3 divided by 1 is 3. So my rate of change between 0.214 and 311 is 3. So that's when you have a graph. You have to see the points or be able to identify the points, the ordered pair, so that you can calculate the rate of change. What happens, however, if you have a formula? Well, we need to have 2 points in order to calculate a rate of change on a formula for a quadratic function. So the way that you do that is when you have it in written form instead of a picture and showing you the points, it says over the interval -2 to 0. So this is saying when x is -2 That's going to be your first ordered pair, the x in your first ordered pair. And when your x is 0, that's the x in your second ordered pair. So here's how you do that. We know we're going to have 2 ordered pairs to figure out what our slope is. We know the x in the first one is -2. We know the x in the second one is 0. Okay, and so here we're going to take and plug in the -2 to this equation. Let's put parentheses around that. I like that better. All right, I do not have my calculator with me today, so I'm going to have to figure this out in my head. -2 times 2 is going to be 4, times 2 is 8. 8 times -2 is -16, and then plus 3. 8 minus 16 is -8 plus 3. We're going to, since they're different signs, we're going to find the difference. So I think it's 5, 6, 7, 8. It is a difference of 5. And it will keep the sign of the larger number, so negative. So it's -5. All right, so we need to do the same thing and plug it in. Plug in 0 to our equation to figure out what it's going to be here. Well, if I plug 0 in for this x and 0 in for this x, they would cancel, and I'd just be left with 3. And that lines up because we remember that 3 is our y-intercept. So when x is 0, we know we have our y-intercept. So that makes sense right there. Now that we have that information, we can go ahead and use our formula change in y over change in x to figure out what our slope or our rate of change is going to be. So figure out which one you want to have as 0.1. I'm going to call this one 0.1 and this one 0.2. All right, so change in y. I need to put my y's first. 0.1 is 3, and then x is 0, and I'm going to put minus here. Then 0.2 is next. I'm going to put my y up top. It's a -5, so my negative will change this minus to a plus. And then the 2 goes down at the bottom. And since it's a negative, it's going to change my minus to a plus. So 3 plus 5, 5, 6, 7, 8 is on top. And 0 plus 2 is 2 on the bottom. 8 divided by 2 is 4. So 4m slope rate of change between these 2 points is 4. Now go ahead and pause the video, complete these second 2 practice problems on your own, and then come back and we'll go over them. All right, welcome back. So we've got 2 points. We're going to go ahead and figure out what those points are. The first point is going to start with 3 as the x. The second point is going to have 4 as the x. Now I need to plug that into my calculator here. So if I have negative and then 3 squared, and 3 is in parentheses. The negative is not. Be sure you keep that negative outside of the parentheses. We're only inserting the 3 to the x spot. Okay, plus 4 times 3 plus 2. So 3 squared is 9. So this is -9 because you square it, then you add the negative on there. And then plus 4 times 3 is 12 and plus 2. And I do highly encourage you, if you have a calculator, to go ahead and use that. I just don't happen to have mine on me right now. All right, so -9 plus 12 plus 2. Well, this is going to be -9 plus 14. So if we have different signs, we need to find the difference. 9, 10, 11, 12, 13, 14. The difference is 5. Which of these numbers is bigger? 14 is bigger. So it's going to, 5 is going to have the positive sign right there. So we're going to put a 5 right there. And then I'm going to insert my number 4 for my x. So negative stays outside the parentheses again. Squared plus 4 times 4 plus 2. So 4 squared is going to be -16 plus +16 plus 2. I can already see this answer because this -16 and +16 are going to cancel out. And so my answer is just simply going to be 2. Now I need to find the difference of the y's and the difference of the x's. So I need to, excuse me, I need to indicate which one's going to be 0.1 and which will be 0.2. We'll call that one 0.1 and that one 0.2. So y's on top, 5, x on the bottom, 3. I put my minus signs in. Y's on top, 2, x on the bottom, 4. So 5 minus 2 is 3. 3 minus 4 is -1. They're different signs. This is a positive here, right? And that's a negative. So if they're different signs, we find the difference. 4 minus 3, the difference between those is 1. And 4 is the bigger number, so we get the negative sign. So this is 3 divided by -1, which is -3, which is our slope or our rate of change between 0.35 and 0.42. All right, so we've got one more problem here, and hopefully I have enough room. Maybe I'll be able to use some on the side here. We're going to calculate the rate of change between these 2 points. This is 1x of the points, and then this is going to be the other x, right? -1. So we got to insert this -4 into this problem. It's going to be 1/2, and this time the negative is inside the parentheses before you square it, right? Plus 5 times -4 minus 4. All right, so -4 squared is going to be a positive 16, and 1/2 of positive 16 is 8. And then 5 times -4 is -20, and then that's -4. So I've got a same sign here, -20 and -4. So I'm going to go ahead and combine those and just make it -24. And now I've got two different signs. I've got a positive 8 and a -24. So if we've got different signs, we find the difference. And so the difference between 24 and 8, well, 24, if I take away 4, that's 20. So I need to take away 4 more to get to 8. So 16, 17, 18, 19, 20. Yep. So 16 is the difference. Let's just make sure. 16, 17, 18, 19, 20, 21, 22, 23, 24. So I did. That was 8 different between them. And what is going to be the sign that goes before my 16? Well, I take the answer takes the sign of the larger number. And in this case, 24 has a larger value than 8 does. So my answer is going to be -16. All right. Now, let's look at the second x, my -1. Let's plug that in. I've got 1/2. -1 is in parentheses. And again, if you have a calculator, this is going to go much faster for you because you won't have to do the work out. And I always encourage you to use that calculator. All right, so -1 squared is a positive 1 times 1/2. So this is still just 1/2. Plus 5 times -1 is -5. And then we've got a -4 right there. So a -5 and a -4 become -9. Because if we have the same sign, we combine, right? So 1/2 minus 9 is going to equal a -8.5. Because if there are different signs, this is positive, and then we find the difference. What's the difference between 9 and 1/2? Well, 8.5 is the difference, and the bigger number, the bigger value, gives the answer its sign. So it's -8.5. All right, so now we need to figure out what the slope is going to be, and we do that by finding the change in y over the change in x. So I'm going to start with, let's just call this 0.1, and this one will be 0.2. So I'm going to put the y first, -16. My x is on the bottom, -4. Then I'm going to throw a minus sign after that. Okay, done with 0.1. Let's move on to 0.2. -8.5. So my minus will change to a plus because of my negative, and I'm going to put 8.5 right there. And then I've got -4 minus, well, it's -1. So my minus will become a positive and have a 1 there. All right, so I've got -16 plus 8.5. If you notice, there's a minus and a plus. So we have different signs. So we need to find the difference. Well, the difference between 16 and 8 is 8. So what's the difference between 16 and 8.5? Is it going to be 8.5 or 7.5? Well, if we had 16 and we took away 8, we get 8. If we take away a half more, you're going to have 7.5. So that's what our number will be, 7.5. Now, what sign should this have? 16 is the bigger number, so you're going to put a negative in front of that. Here we again have two different signs, a negative and a positive. So with different signs, we find the difference. The difference between 4 and 1 is 3, and 4 is the larger number. So we're going to give our answer a negative. Now, when you multiply or divide, an even number of negatives create a positive. If you have an odd number of negatives, your answer will be negative. So here we have two negatives. So it means our answer is going to be positive. 7.5 divided by 3, 7.5 divided by 3, 7.5 divided by 3. I would have no clue what that is. I've got a phone. It's not a fancy calculator. It's going to be like 2. Yeah, it's 2.5. Okay. So our answer is 2.5. All right. So our slope, that's what we were finding out. Our slope is 2.5. So you're able to, and actually, so 2.5, you would put that as what, 3/2? No, 5/2. It would be 5/2 for your final answer if you were to answer this, because 2.5 as a fraction would be 5/2. All right, so we need to move on. Let's look at, remember we said that a linear function had a constant slope, right? Well, no matter which 2 points you took. So one problem you're going to get when you come across these in your homework and your quizzes and tests is you're going to be given a table of points. And it's going to tell you this is a function. Now, we're not asking you to graph it, but I want you to look at these points and tell me whether it's a linear function, a quadratic function, or neither. And the way that we do that is we're going to look at the slope and see what the slope tells us about it. So remember, our slope is change in y over change in x. And I'm hoping this is quadratic because I forgot to give an example problem before we jumped into the practice, but here we go. All right, so the difference, the change in x, if you notice, the change in x is always 1. And when you divide by 1, in this case, in this table, it's 1. Now, it might not always be, so you should always verify that. But anything you divide by 1 is going to be what? It's going to be itself, right? So in this case, we don't need to look at the x's at all. We only need to consider the y's, or in this case, the outputs, because it's called f of x up here. So what's the difference between -9 and -2? It's going to be a difference of 7. 9 minus 2 is 7. So what's the difference between 2 and 1? It's going to be 1. Oh, wonderful. And then what's the difference between 1 and 0? Well, that's also 1. And what's the difference between 0 and 5? This one's not a quadratic function, is going to be 5. All right, so this is what we call the change one, the change between each of these functions, okay? And if this is constant, it would be a linear function. If it was not constant, it can either be a quadratic or neither, all right? It has to be constant on change 1. Change 1 is constant, okay? Since that's not constant, we know it is not linear, okay? So for it to be quadratic, there's going to be something called change 2, and that has to be constant in order for it to be quadratic. Now, what change 2 is when you find the change between these changes, right? So what's the difference between 7 and 1? It's 6. What's the difference between 1 and 1? It's 0. And what's the difference between 1 and 5? It's 5. So this is change 2. And those are not constant. So this is not a quadratic function either. This is neither. So since this was neither, I'm going to, before I make you do the other 2 practices, let's come up with, let's just do y equals x squared as our quadratic function. We know this one is quadratic. And then let's put a linear function here. And let's say y equals 2x plus 3. And remember, we know this is linear because the x is not raised to any power. It's got a power of 1 in the variable. And this is quadratic because the x, or the variable, has a power of 2. So it's quadratic here. So let's create our own little charts for the x's and the y's, because I want to show you what a quadratic looks like. So if we plugged in, let's say 0, 1, 2, and 3 for each of these, because we want to keep them 1 apart. The x, I like to keep 1 apart so that I only have to look at the y's. So if I plug 0 into here, my y is going to be 3. If I plug 1 into this, it's going to be 5. If I plug 2, 4, 5, 6, 7, 3 is 6, 7, 8, 9. So there we go. And then let's fill out this chart. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. All right, so let's look at the change here. These, remember, 0 to 1 is 1, 1 to 2 is 1, 2 to 3 is 1. So we don't need to be concerned with the x's, because dividing by 1 is not going to change our answer at all. So let's just look at the change in the y. So the difference between 5 and 3 is 2. The difference between 7 and 5 is 2, and the difference between 9 and 7 is 2. This is constant because it's the same number all the time. And this is our change 1. Okay, so it's our first, our change in these numbers, right? So we can tell that this is linear just because of the slope, because it's always constant. It's going to look like a line. It's a linear function. Now let's look at this quadratic, and we know it's quadratic because we started with it, so we already know that. So let's look at what this is going to do, how this is different from this linear one. 0 to 1, 1, 1 to 2, 1, 2 to 3, 1. So we don't need to be concerned with the x's because dividing by 1 isn't going to change our slope at all. So let's just look at the y's. The difference between 0 and 1 is 1. The difference between 1 and 4 is 3. And the difference between 9 and 4, 5, 6, 7, 8, 9, is 5, right? Well, that's change 1. And we see that that's not constant. So change 2, we're going to find the difference between our first differences. And so the difference between 1 and 3 is 2. And the difference between 3 and 5 is also 2. And this is change 2. And in this plate, this is constant because it is a quadratic. Now, if you find change 1 is not constant and change 2 is not constant, just like we had here with this problem, then your answer would be neither. So change linear, your first differences, your change 1 will be constant. Quadratic, your change 2 will be constant. Neither means that neither change 1 or change 2 is constant. Okay. All right. So now you need to do practice 2, and I've got one more after this. I want you to do them on your own and see if it's linear, quadratic, or neither. And then unpause the video and we'll go over them. All right. So let's look. -2 to 1 is 1. 1 to 0 is 1. 0 to 1, 1. 1 to 2 is 1. So we only need to focus on the y's. So the difference between 16 and 8 is 8. The difference between 8 and 4 is 4. The difference between 4 and 2 is 2. And 2 and 1 is 1. So we can already see that change 1 is not constant. So it is not a linear function, right? So let's move on to change 2. The difference between 8 and 4 is 4. The difference between 4 and 2 is 2. And the difference between 2 and 1 is 1. So it is not quadratic. This is neither again. All right, practice 3. Check this one out. See if you can figure this one out. -2 and 1 is going to be a difference of 1. 1 and 0, difference of 1. 1. So x's we're not concerned with. We can focus just on the y's. All right, so between 17 and 13, 13, 14, 15, 16, 17, difference is 4. 13 and 9 should be 4 as well, but 9, 10, 11, 12, 13. And 5 and 9, 5, 6, 7, 8, 9. and 5 and 1, 1, 2, 3, 4, 5, and they're all 4. So in this case, since change 1 is constant, it's a linear function. All right, so hopefully you can see how to tell the differences between linear, quadratic, or if it's neither of those, just from looking at a chart. But also after this lesson, you should be able to tell what the slope is between 2 points on a quadratic function. So I look forward to seeing you